Okay, good morning, everyone. So for today, I would like to share about one topic called row factor, or so I mean row space, column space, and null space. So hope this can help you to understand more about this material. I will start with the definition. Give you matrix with m times n size. And within this metric, we can take the factors. Yeah, the factors. We call this as R1 to Rm. So the R1 is a factor contain A11, A12 till A1n, R2, A21, A22 until A2n, and so on until Rm. This is the factor called row. R is the row, yeah, row factor M, which is the last row in the matrix. Okay, in Rn, yeah, form the rows of A called the row factors, as I mentioned before. This called R1 till Rm called as the row factor of A. Yeah, and if you see from the point of view of column, so you have here A11, A21, A M, oops, uh, A11, A21 until A M1. This is come from the column. Yeah, this is column 2 until column N. So we have these things called as column factors of A. Okay, for example, if we have such a matrix A here, 2 times 3. So the row factor is the member of the matrix in the form of row. Here is 2, 1, 0. This is R1. And the second one is 3 minus 1, 4. This is R2. And the column factor is 2, 3. This is column 1. This one is column 2. And 0, 4 is the column 3. Okay. And next we continue with the row space and column space. So previously you know about row factor, column factor. Now we move to row space and column space. As we have previously, if we have A is M times N matrix, then subspace of Rn, ya, ruang dari Rn spanned by the row factor of A. Merentang, ya, direntangkan oleh vektor-vektor baris dari A, disebut sebagai row space. Dan subruang, ya, subspace of Rm, ya, direntangkan, ya, oleh vektor-vektor kolomnya, dan di sini disebut sebagai column space of A. Nah, solusi dari kalau kita mempunyai if we have a homogeneous system linear equation, yeah, we know that homogeneous system linear equation is in a form of ax equals 0, for example, and we have a solution, yeah, solution of this equation, yeah, this equation is the subspace of Rn, and this can be named as null space of matrix A. So we have here subspace of Rn, yeah, spanned by the row factor of A. We call this as row space. And if the subspace of Rm spanned by the column factor is called the column space. So yeah, this is similar to the previous. So okay, I will not approve this theorem, but you need to consider this. We have theorema, yeah. If we have SPL, system of linear equation AX equal B, we call this as consistent if and only if B is in the column space of A. So we need to check whether the P, yeah, the P here is in the column space of A. Okay, to be more specific, let's check the example. So here we have example, yeah, system linear equation, SPL, yeah, linear equation system. We have here A, for example, AX equal to, hold on a second, I need to move this, okay. AX equal to B, yeah. We need to show whether B is in the column space, yeah. As previous slide mentioned, we call this, if it happened, then as previous mentioned, we call the system of linear equation is consistent. So we will check whether the P, yeah, the P is in the column space or not. Yeah. If we want to know whether the P is in the column space of or not, we need to express P as linear combination of the column vector of A. So you need to do, yeah, to find the X, yeah, to find the X, yeah, you can use Gaussian elimination or other things, other strategy, and you find x1 is equal to, x2 is equals -1, and x3 equal to 3. Okay, so here the system, yeah, the system is consistent. So we can say that the P is the column, is in the column space of A. Yeah. So it's just how to say, just want to prove, yeah. For example, is if x1, so if you multiply the negative 1, 1, 2 to x1, yeah, okay, and so on 3 to, yeah, okay, it just a follow, yeah, follow, because you just put like the x1, x2, x3, and you check whether the result is 1, -9, and -3, and this is a consistent system. Okay, hope it's make you clear, yeah. Yeah, so far what I explained is still connected to the linear equation system. Yeah, the solution of linear equation system. If we have a consistent linear equation system and the solution is a single or one solution, yeah, and if we have a factor, yeah, let's say factor 1, factor 2 until factor k, which is membentuk, form a basis for the null space of A. So we will check, yeah, we will check that phi1, phi2, phi form the basis for the null space, and by form a basis for the null space, then the solution space, yeah, the phi1, phi2 until phi k is the solution space of the homogeneous system. Yeah. So that every solution of ax equal to b, yeah, can be expressed, can be shown by hold on a second. Yeah, can be expressed in the form of this thing. So we have x equal to x0 plus c1, v1, and so on. It's like polynomial things, yeah. So what is the c? The c is the scalar, yeah. And what is the x? The x is the solution, yeah. The solution, the factor is in this formula in here is the solution of ax equal to b. Okay, to make you more have more insight. Okay. Okay, let me. Okay. So, for example, you have like a non-homogeneous system. Actually, this is just SPL, yeah, linear equation system. If you try to transform, this can be in this form ax equal b. Yeah. So you can do the, yeah, I asked you to do the to find the solution. Do it, yeah. Do try to find the solution, yeah. Solution of this system of linear equation, and we have this result. You can check. For example, x1 is minus 3r minus 4s minus 2t. X2, we determine this as r. X3 is x4 is the s, x5 is the t, and we have x1 until x6. This is the solution. We will transform the solution in this way. Yeah. So for example, x1 is minus 3r minus 4s minus 2t. We will see. Yeah. Okay. Yeah. If in manual things, yeah, we do like this. Minus 3. Oh, sorry, I need to clear it up. Okay, hold on a second. Oh. Okay. So you need to make this thing first. You need to make like, oh, we have RS and T. Okay, x1 minus 3r plus minus 4s minus 2t r. This is yeah, r is this is 1. We don't have any other, so we can put 0. S is minus 2 here. Okay, with no t. And t is here 1 and 1/3 that don't have any relation to RS. So you need to make one other column factor, called 1/3. Yeah. So if you see here, this is called x0. And the text, yeah, the result with corresponding to RST, we call this as x. Yeah. This is called the general solution. Yeah. This is the general solution. However, we name another other thing. So for x0, this x0, the factor x0 is particular solution. Particular solusi khusus, particular solution. And linear combination, ya, ini kan kombinasi linear ini, ya, dalam X ini ya, kombinasi linear. Jadi min 3R plus min 4S plus minus 2T, ya. This called as linear combination of X. And this one called general solution. Why general? You can put any R, any S, any T to this solution. Okay.